the question is, if z is function of u and v, and u is equal to x cos theta minus y sin theta, v is equal to x sin theta minus y cos theta, then show that x del z del x plus y del z del y is equal to u del z del u plus v del z del v. Now, this question is based on the composite function as well as change of independent variable. Why it is called change of independent variable? Just see the last expression which we have to prove over here. Here the dependent variable is z in both the sides, but in the left hand side x and y are independent variable, but in the right hand side u and v are independent variables. So this is the question which comes under the change of independent variable. So now, with the help of partial derivatives, we are also able to change the independent variables. So how to do it? Let us go ahead. We have given that z is equal to f of u v, or z is function of u and v. Let us give it equation number 1. Similarly, u is equal to x cos theta minus y sin theta. v is equal to x sin theta minus y cos theta. Let us give it equation number 3. Now, then we have to prove that x del z del x plus y del z del y, which is equal to u del z del u plus v del z del v. Here z is function of u and v, and u and v are functions of x and y. So z is composite function of x and y. Therefore, del z del x, which can be written as del z del u del x plus del z del v into del v del x. Similarly, give it equation number 4. Similarly, del z del y is del z del u into del u del y plus del z del v into del v del y. So this is called composite function. Z is composite function of x. So we can write down, we can find out what is partial derivative of z with respect to x. Similarly, what is the partial derivative of z with respect to y. Now, since u is function of x and y and v is also function of x and y, so we are able to find out what is the partial derivative of u with respect to x, what is the partial derivative of v with respect to u x, what is the partial derivative of u with respect to y, and what is the partial derivative of v with respect to y. With the help of this equation number 2 and 3, let us try to calculate these 4 things, and after getting this, we substitute all these values in equation number 4 and 5. Then most probably, and we multiply x and y on both the sides, then and adding them, then definitely we get our answer. So now differentiating 2 and 3 partially with respect to x, we have the u is given, u is equal to x cos theta minus y sin theta, v is equal to x sin theta minus y cos theta. So if we differentiate this with respect to x, cos theta is constant and derivative of x with respect to x is 1, so we have only cos theta. If you want to differentiate u with respect to y, this term will be constant, and sin theta is constant, so minus sin theta. Similarly, if you want to find out del v del x, so the sin theta is constant and derivative of x is 1, so del v del x is equal to sin theta. And similarly, what is del v del y? So this is free from y, it will be the derivative of this is 0 and derivative of y is 1, so we have only minus cos theta. Putting above values in 4 and 5, we have del z del x, which is equal to del z del u from the equation number 4, and the value of del u del x, this is equal to cos theta, plus del z del v, and the value of del u del v del x, this is nothing but sin theta, and similarly del z del y, so del z del u and del u del y, what is del u del y is minus sin theta, and then del z del v del y, so del v del y is minus, again minus cos theta. So now if we substituting all these values, these are the values of del u del x, del u del y, del u del x, del v del y, sorry, del v del x, then del u del y and del v del y. Now multiplying equation number 6, this equation, we have to multiply this equation by x and this by y, then x del z del x and adding them plus y del z del y. So we have to multiply this by x, multiply this by y and adding them. So just look here, we are multiplying this by x. So x into del z del u into cos theta plus x into del z del v into sin theta. And this will become, we have to multiply this by minus, y. So minus y del z del u into sin theta minus, we can take outside, minus y del z del v into cos theta. Let us take the common derivatives del z del u and del z del u. So what is the coefficient of del z del u? It is x cos theta. And similarly, what is the coefficient of del z del u? It is again minus y sin theta. So x cos theta minus y sin theta into del z del u. Now the remaining two terms are remaining. So this is x sin theta. If we take del z del v is common, del z del v is common. So x into sin theta and minus y cos theta. But we know that what is x cos theta minus y sin theta? It is nothing but u, and x sin theta minus y cos theta, it is nothing but v. It is nothing but v. So now we can substitute the value of x cos theta minus y sin theta is u, and x sin theta minus y cos theta is equal to v. So this can be converted as x del z del x plus y del z del y left hand side, which is equal to, this is what, u del z del x del z del u plus this is v del z del v. And this is the desired result, hence proved. Thank you.